In this warm-up, we are using the distributive property to multiply. So the number or value outside of the parentheses will get multiplied to the pieces inside the parentheses. 1/2 times 4 would be 2, so 1/2 times 4x is 2x. 1/2 times 6 is 3. These are not like terms. This is a variable term and this is a constant term, so we cannot combine them. In this one, we would have 5 times x and 3 times x. There's an addition in the middle, so we'll keep that. But since these ones are both variable terms and they're using the same type of variable, we can combine those to make 8x. 5x plus 3x is 8x pieces. Sean and Noor work as pet sitters. Sean earns the same amount of money each day. Noor earns $4 more than Sean each day. What are some amounts Sean and Noor might earn each day? Well, if Sean earns $10 each day and Noor earns $4 more, $4 more than 10 would be 14. That's just one example. What if Sean earns $205? Then Noor would earn 209 because that is 4 more than 205. Write an expression that represents the number of dollars Noor earns if she and Sean each work for 5 days. Let W represent the amount Sean earns in dollars each day. So here is Sean's. He earns W dollars each day, and he works for 5 days. So 5 times W. Well, Noor has the same amount that Sean earns per day, but $4 more than that. This is the amount she earns in 1 day. So for 5 days, she would earn 5 times that amount. We could also rewrite this as 5W plus 20 because 4 days or 4 times 5 days is 20 extra dollars. Now we're going to draw a tape diagram that models the expression we wrote. So we have Sean with 5 days of earning W dollars. And Noor, each day she earns W and 4, but we need 5 of those. So 1, 2, 3, 4, 5 days. But you could regroup it so that you have your W's together and your 4's together. So there's 1, 2, 3, 4, 5 W's and 1, 2, 3, 4, 5 4's. So which one of these would be the correct representation for Noor? A, because it shows up $4 extra every single day, whereas B only shows $4 extra one time. We could correct it by putting 5 4's and 5 W's. Now these two tape diagrams are equivalent, they're just different ways to represent it. You could also think of it as each day, 1, 2, 3, 4, 5 days. This is the area model in comparison to the tape diagram. So we're going to write an expression equivalent to 3 times W plus 4. 3 W's would be 3W, and 3 sets of 4 is 12. So this would be 3W plus 12. Here, the -2 is outside of the parentheses, and W plus 4 is inside. Try and answer the area model. -2 times W is -2W, and -2 times 4 is -8. So we can write the expression like so. Give 4 through 6 a try on your own. You can pause the video here to give yourself some extra time, then resume to check your work. Can I use the distributive property? In the problems we had been working with, we used addition or subtraction within our parentheses. Do you think it's possible to use the distributive property when there's multiplication inside of the parentheses? In this case, we cannot use the distributive property because this here is x times 4, or 4x. So we would multiply -2 times 4x to get -8x. But we wouldn't want to distribute because we already have the multiplication existing inside the parentheses. If we try to distribute, that would be -2x and +8, or -8. But if we multiplied, that would give us 16x, not -8x. So we cannot use the distributive property because there's multiplication occurring inside of our parentheses. We want to do the operation and then multiply by -2. Do you think that either of these students are correct? This student said 5 times W is 5W and then divide by 4. This one said 5 times W is 5W, but 5 times 4 would be 20. And then the negatives are thrown in there also. So -5, -5, and -20. Well, let's think of it as a fraction. This would be W over 4 times -5. So -5 over 1, we would do -5 times the W, but 1 times the 4. So that's -5W divided by 4. So this student has a correct representation. When we have multiplication or division inside, we do not want to distribute in the same way that we do with addition or subtraction, because then we're multiplying and dividing by 5. It would be like putting the 5 down here. 5 times 4 would be 20. But we don't want to change it by 1, we want to change it by 5. So the distributive property really only works in the way that we used it with addition and subtraction. And that's the end of lesson 2.